Hello guys, welcome back for another video. Welcome back to your own community. So today we'll be talking about and we'll be coding, and I'll be showing you guys at the same time how does a linear regression works. I'll be showing you guys some charts, some plots, some data plots and everything, and we will also have a data set, and I will show you guys the Pearson correlation coefficient linear regression and the gradient descent. So guys, let's do this. So at first we have the Pearson correlation coefficient. So the code for the linear regression Pearson is very simple. Yeah, so here we have the Pearson correlation coefficient. So I coded it before, so I just wanted to go over it. It's very simple. So again, a quick summary of what's Pearson correlation coefficient. So linear regression is finding the prediction for our data, and the Pearson correlation coefficient is tells us where this two data goes to, or it's more like the direction of the data, and as opposed to gradient descent is more like gives us the best fit for our linear model. So here here we have so here I just put it down there if in case you forgot or you don't get lost. So we're basically coding this function, and that's simply that's what Pearson correlation coefficient is. So here we have a x hat, y hat. So the formula for Pearson correlation coefficient is this. So if we see on the right side of my screen, so y equals to, it's the same thing as y equals to mx plus b. So here we see that our slope in here, it's equal to r, which is the Pearson correlation coefficient, times the standard deviation of y, and divided by the standard deviation of x. And we see our y-intercept is equal to y hat minus the slope times x hat. So that's why first we want to find our x hat and y hat. So x hat and y hat is basically it's sum of all the values for x divided by the length of the x, which is the number of the element of x. Same goes for y. So we have our x hat and y hat. Now what we want to do, we want to find r, which is equal to the summation of I equals to 1 till n, and x minus x hat and times y minus y hat divided by the square root of the same thing as our upper function, but basically squared, because we want to find the mean square error. So with that being said, we'll get to coding. So first, right now our goal is to find r. So I made it as simple as possible. So I made a variable called upper function, which is the summation of I to n x minus x hat times y minus y hat, which is very simple here, as you can see in the code. And I made a lower function, because I made two lower functions because we have two square roots, and I basically calculated each separately and then multiplied them and assigned it to res. I used the squared from the math library, which I have it imported here. So then I have my r assigned to upper function, which is this. So this would be my upper function, and then this would be my lower function, which I have assigned it to res. So and that would be my r, and standard deviation of x and y is very simple. So the formula for standard deviation of y is simply the square root of y minus y hat squared divided by the number of elements. So once we have that, we find our m just by r times standard deviation of y divided by standard deviation of x. So our b is equal to y hat minus x times that. That's our y-intercept. So then we return these two variables, and then we have another function which is predict, which takes three values. And so here we don't actually need this this variable list x, but I just kept it there to make sense, because it's think of it as like we have our function y equals to mx plus b, and we want to find values for y, but we have found values for a, b, and x. So we're just gonna put values for a, b, and x, and then we're just gonna get a bunch of y values which we're gonna add and list y. So which we have done it here, and then we return list y. So here we have an x and y values to test our methods, and we do so by calling the function a gradient descent and getting our slope and y-intercept. And here we're assigning the list y to new y, and then we're predicting, we're plotting those lines, the y values which we got along with the x values, and we're showing them. So we're gonna run and we're gonna see what we get, and we're gonna play a little bit with our x and y values. And now we're gonna do Python 3. So here we see, because we don't have many values for x and y, that's why we got less values. So now we could see that this is our Pierson correlation coefficient linear regression. Now we're gonna test it with much more values. We're gonna give it 80 values, and we're gonna test them to see. Okay, it worked. So here, as we could see, it's giving us a weird graph. It's because we have added really random values. So that's it for the Pierson correlation coefficient, and in another video I will explain the gradient descent, and we have a data file, and we're gonna test the gradient descent on the data file, which is even more fun. I'll see you in the next video. Ciao.